Welcome, my friends. Let's talk about inheritance. Now, all object-oriented programming languages have inheritance, polymorphism, things of that nature. But Python's a little bit different. The last video, we talked about how coming from a C++ Java world, I noticed that there aren't access modifiers for public, private, protected. Of course, that means something if you have that background. That's because everything is public. That's the default. So we can simulate encapsulation in Python, but everything is public. So inheritance takes it up a notch. And so let's drill down on that. I'm Professor Benavides, and we're taking it up a notch on OOP, Object-Oriented Programming, Chapter 9, and we're drilling down into inheritance. So what is inheritance and why is it used? You don't always have to start from scratch when writing a class. If the class you're writing is a specialized version of another class that you wrote, you could use inheritance. When one class inherits from another, it takes on the attributes and methods of the first class. The original class is called the parent class, and the new class is the child class. The child class can inherit any or all of the attributes and methods of its parent class, but it's also free to define new attributes and methods of its own. That's going to be one of the key ideas that we're going to be talking about in this section. Now, the init method of the child class is what we want to talk about right now. So why call the init method, or shall I say the init method for a child class? Why call the init method from a parent class? So when you're writing a new class based upon an existing class, you'll often want to call the init method from the parent class. This will initialize any attributes that were defined in the parent init method and make them available in the child class. Can you provide an example? Let's drill down on that. As an example, let's model an electric car. An electric car is just a specific kind of car. So we can base our new electric car class on the car class we wrote earlier. Then we'll only have to write code for the attributes and behaviors specific to the electric cars. We start with car. When you create a child class, the parent class must be part of the current file and must appear before the child class in the file. So here we have an example here. Now, first of all, I want to tell you, yes, everything's all in one file. Our classes that many times other languages refer to as providing a service, and then when we instantiate the object, that's pretty much called a client, right? Because the client is using the service. Typically, we will put everything into separate files so that it's more modular, but when you're first starting out, it's so much easier to see everything all on one page, or excuse me, all on one file. That's why this little demonstration here is all in one file. And if it's all in one file, you're going to have the parent class first. Okay, so let me collapse everything so we can see the structure of this first demo. Okay. So in a sense, I could probably say there's three parts to this demo. The first part is our parent class called car. The second part is the child class that we're going to call electric car that inherits from car. The way you inherit is in the class definition, in the parentheses, you go ahead and pass car. Then we can go ahead and create instances and print out or access methods of that particular instance or object. Okay, so what we're going to do here is we start with car. So let me go ahead and drill down on car a little bit, and then we'll talk about the electric car, and then we'll talk about it, creating an object of the electrical car, how that all works. So let's review what's inside of car first. So the class car has this. It's got an init method. Other languages call this a constructor. Now this happens, the init method is called when you create your object, right? So when I create my object, I'm going to be passing make, model, and year. That then becomes these attribute variables or instance variables, right? And then we have also 1, 2, 3, 4 special methods. One called get descriptive name, another one called read odometer, another one called update odometer, and another one called increment odometer, which has a shorthand abbreviation in here for incrementation, or accumulation, an accumulator for the odometer reading. All right, so that's the structure of car. It has two things. It has attributes and it has behaviors. The attributes are the data at the top, and then the behaviors are exhibited by methods, right? So this is the representation of a car. In our modeling of a car, we're going to include make, model, and year. As far as what actions occur, we can go ahead and describe the car, we can read the odometer, we can update the odometer, and we can increment the odometer. I know these two are fairly similar ideas, but they go ahead and do slightly different things. So now let's drill down. So this is what we're going to call the parent class, right? We're going to inherit from car. So the car is called the super class, right? And then electric car is the subclass, because it's, in other words, it's the child, right? So we have a parent-child relationship on here. So let's drill down on the child. So inside the child, in this particular case, I don't see any methods. All I see is the init method, right? So inside the init method, we have something very important here. Very, 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 very important. Super keyword. So I've already used the word superclass. So what does this do? This gives us the ability to access the init method of the parent. So in other words, in inheritance, when I create my electric car, instead of writing the code that, for make, model, year, and odometer reading, why don't I just inherit that? So I get that done by typing one line of code. And then later on, we're going to see how we can add more code that is specific to the electric car. So, but first of all, we're going to start off by simply inheriting from car. And then what we're going to do is we're going to build on the electric car class to make it an electric car. Okay. So again, line 35 is really important here, because the super keyword, the super method, allows us to access the init method. And then we go ahead and create an instance on line 38 called my Tesla, gets electric car, and I pass it Tesla Model S 2019. And then I go ahead and call one method. I know it has several other methods, but we're just going to call one called the descriptive method. So let's go ahead and run it real fast, and I'll if I need to, I'll go down on it again. Of course, I'm using Visual Studio Code right now, and we see the output is simply one line of code on here, because we're calling the get descriptive name. And if you look on here, the get descriptive name creates a string consisting of year, make, and model, and returns that. Okay, so that's how and why we're able to, so we're able to use code that's already been written. Do I have the descriptive name method inside of the class for electric car? No. Well, how did I get that? I got this method because I inherited it from car. So I'm already seeing a little bit of benefit of inheritance here. And what we need to do now is make the electric car different from car. So we're going to go ahead and add more features to the electric car to make it specific. For right now, let's remember that the init method takes the information required to make a car instance. The super function is a special function that allows you to call the method from the parent class. This line tells Python to call the init method from car, which gives an electric car instance all the attributes defined in that method. The name super comes from a convention of calling the parent class a superclass and the child class a subclass. We test whether inheritance is working properly by trying to create an electric car with the same kind of information we provided when making a regular car. We make an instance of electric car and assign it to my Tesla. This line calls the init method defined electric car, which in turn tells Python to call the init method defined in the parent class. We provide the arguments Tesla Model S and 2019. Talking about right here. This is where we create our instance, right? On line 38. Okay. This line right here is what I'm talking about. Aside from the init method, there's no attributes or methods yet that are particular to the electric car. At this point, we're just making sure that the electric car has the appropriate car behaviors. Okay. So now let's go ahead and talk about defining attributes and methods of a child class. Let's go on to our next little example here. So once you have a child class that inherits from parent, you can add any new attributes and methods necessary to differentiate the class from the parent class. So what we're going to do here is we're going to add a new attribute called self.battery_size and set its initial value to, say, 75. This attribute will be associated with all instances created from the electric car class, but won't be associated with any instances of car. We also add a method called describe_battery that prints the information about the battery. And when we call this method, we get a description that clearly specifies the electric car. Okay, so let's go ahead and drill down on that. So this is all about defining attributes and methods for the child class. So the car class, I'm going to collapse that, and let's just look at the electric car. What's new here? Okay, so we already had the super keyword, right? Discussed. This is new right here on line 37. We added this line. So we added an attribute. The attribute that we're adding is self.battery_size gets 75, right? And we're adding a method called describe_battery. And all it is, it just describes the battery. It's going to end up saying this car has a 75 kilowatt battery. So then when we instantiate the object on line 43 and then print out the descriptive name, we then call the new method from the electric car. Right? So again, here's car. It's unchanged. This is the parent right here. The car class is the parent. And we engage in inheritance. On line 28, we create the magic that occurs here on this line says that electric car inherits from car. So then inside of the child, I then access the init method of the parent and add a new attribute. So this new attribute is in addition to these other ones, make, model, and year. Okay, so that when I run this, let me go ahead and run this. I am getting The first line here, 2019 Tesla Model S, that is coming, that is coming from the description. So in the description here, it says year, make, and model, and then it's returned. So when I went ahead and said, after I created my instance, and I say my Tesla dot get descriptive name, I'm utilizing that method from the parent. Then when I say my Tesla dot describe battery, like say for example, if I think it's more informative if I type in the code here. So I would say my underscore Tesla dot. See how from this drop down list I can choose the get descriptive name, which I already did, or I can choose the describe battery. I can access the battery size directly from here as well. Remember, we talked about how everything is public, right? So the dot notation here shows us that I can, because I'm using inheritance, I can go ahead and use the methods, right? The methods that are in not only the parent, but in the child. Now notice the little icon differences on the drop down. This little icon signifies that it is a method. These other ones here, battery size, make, model, odometer reading, year, those are the attributes. See how we have the attributes here? We have make, model, year, odometer reading. Those are the attributes. So I could go ahead and access them and change them from here. We'll talk about that in the next video, but I just wanted to show you and these other icons we'll learn as we go along. But I wanted to show you the importance of dot notation on here. Okay. So that's our second demo on here. Let's go ahead and go on to our next little demonstration here. And this one is called overriding methods from the parent class. Remember I talked about how OOP languages, object-oriented languages, have class-based programming as well as inheritance, and then they also have polymorphism. Those are the things that they have in common. Your author doesn't use that word, but when you override a method, that's kind of like an example of polymorphism. Or polymorphism means poly means many, morph means forms, it takes many forms. So overriding is an example of that. So is overloading, and there's many others examples. When you take an advanced programming class, you'll find an entire chapter on polymorphism. In your book, you only have like a couple of paragraphs. So hey, let's go ahead and at least understand and what overriding methods means. And that's kind of good and bad about your book. The good is that you just learn what you need to learn. You're going to learn how to override a method from the parent class. What you didn't learn is the fancy words that it's called polymorphism and stuff like that. When you're first starting out, I could probably agree, you probably don't need to know that. But when you advance later on, you will need to be able to have that as part of your vocabulary. So how can you override methods in a parent class? And of course, why? Why? The why is that sometimes you don't want to use the method in the parent, you want to use a method in the child because it doesn't make sense. Let's say, for example, you have a sports car and it's got a different motor than a regular car. Well, then you would want to override the method that creates the car in the parent and use a different method that creates the motor for the sports car. Okay, so that's the why. So how can you override methods from the parent class? You can override any method from the parent class that doesn't fit what you're trying to model with the child class. To do this, you define a method in the child class with the same name as the method you want to override in the parent class. Python will disregard the parent class method and only pay attention to the method you define in the child class. So say the class car has a method called filled gas tank. This method is meaningless for all electric vehicles. I know there's hybrids, but this is an all electric vehicle, right? Okay, so you might want to override this method. Well, actually, you will need to override this method, right? Because shouldn't be part of the manufacturing process, right? So here's one way to do that. We're going to go ahead and look at that. So now if someone tries to call fill gas tank with an electric car, Python will ignore the fill gas tank in the car class and run this code instead. When you use inheritance, you can make your child classes retain what you need and override anything you don't need from the parent class. Okay, so let's see what happens here. Here's our parent class called car. And notice how we've got a method called fill gas tank. Now I added this and I just put, because it was your author talked about it, but he didn't create, he just said, say you got this. So he didn't really provide a real full working program. So he very lightly touches on this topic. So anyway, so I went ahead and just created the method. He says, say you have a method called fill gas tank. So what I created it, and I just said print gas tank is being filled up. I'm assuming that's what fill gas tank means, right? Since he didn't provide a doc definition as to what. Well, actually, he just says he provides a doc definition in the child, but not in the parent, right? So what happens here is we're going to want to override this method. We're not going to want to use that because when we create an instance of electric car, we don't have a gas tank. So what happens here is I create, like the book says, the same definition name again. Exactly the same, but I provide a different functionality. In this case, and we're just using print statements, but we could have a much more elaborate coding structure here, right? I'm just going to say this car doesn't need a gas tank. This is what's going to end up being printed, right? So when we look at our code, again, the way I like to think of it here is we got the parent class, the child class, and then we've got the client. And this is typically this what you see here on lines 44 to 47. Typically, you'll find that in a separate file to have modularity. But when we're first learning, we want to see all three parts all on the screen at one time. So the first thing I do here is I create an instance, and then I go ahead and print out the get descriptive name. Then I go ahead and gain access, or I call the describe battery. And then I go ahead and call the fill gas tank. Okay, so these are all, many times people refer to this as the client because it's used in the service, but those are other terminologies here. So basically what's going to happen here is that when I say my Tesla.fill gas tank, it's going to go and use the one inside of the child rather than the one that's inside the parent. So let's go ahead and run that and verify that. And let's look at what the print statement does. So it says the car has a 75 kilowatt battery. This car does not need a gas tank. Okay, very good. All right, so let's go ahead and talk about instances as attributes. And that's our next topic here. Now this one's fairly unique. I hadn't seen an implementation like this before. So let's put our think caps on here. It's called, this section of the chapter is called instances as attributes. So when modeling something from the real world in code, you may find that you're adding more and more detail to a class. You'll find that you have a growing list of attributes and methods, and that your files are becoming lengthy. Okay, so in these situations, you might recognize that part of one class can be written in a separate class. You can break your large class into smaller classes that work together. And this is just one way of doing that, right? We define a new class called battery that doesn't inherit from any other class. The init method has one parameter, battery size, in addition to itself, in addition to self. This is an optional parameter that sets the battery size to 75 if no value is provided. The method describe battery has been moved to this class as well, or at least that's what the book says. But so in the electric car class, we now add an attribute called self.battery. This line tells Python to create a new instance of battery with a default size of 75 because we're not specifying a value. And assign that instance to attribute self.battery. This will happen every time the init method is called. Any electrical car instance will now have a battery instance created automatically. Okay, so when we create an electric car and assign it to the variable my Tesla, that's what we're going to do. When we want to describe the battery, we need to work through the car's battery attribute. This line tells Python to look at the instance my Tesla, find its battery attribute, and call the method describe battery that's associated with the battery instance stored in the attribute. The output is identical to what we saw previously, but it is designed in a different kind of way. So this looks like a lot of work, but now you can describe the battery in as much detail as we want without cluttering the electric car class. So let's add another method to the battery that reports the range of the car based on the battery size. This new method called get_range performs a simple analysis. If the battery capacity is 75 kilowatts, get range sets the range to 260 miles. And if the capacity is 100 kilowatts, it sets the range to 315. Then it reports the value. And when we want to use this method, we again have to call it through the battery's attribute. The output tells us the range of the car based upon the battery size. Okay, so let's go ahead and look at this. And I'm going to collapse the classes and then just take it one step at a time. Okay, so here again, I see when I collapse this, I've got my what's going to end up being the parent called the car class, right? I know it's going to be the parent because I have class electric car, and it in the parentheses it receives car. This is where inheritance occurs. But now what happened was that I found I found myself creating a very large class, and what we did is we went ahead and we took out some of the code in there from the car class and created a class called battery. So let's go ahead and look at that, because class, it remains unchanged, right? Class remains unchanged, except for the fact that we have extracted the battery information and put it into a separate class. Now, what is it that's occurring here? We've got an init method that has an optional size of 75. It is an optional parameter. And on line 32, I go ahead and assign battery size to the attribute variable. Okay, so it's got one attribute variable. Then we went ahead and moved the describe battery here. We've got the get range, which is new, right? So we went ahead and partitioned this, created this new class called battery as a way of organizing our code, structuring it. And because basically you want to go ahead and if things get too long, we want to make sure that things are represented well. And so now that brings us to the child class. So in the child class, you'll notice it inherits from car. So how in the world do we use battery? Let's go ahead and talk about that, because basically this is called instances as attributes. So what happens here in the child class, in the init method, right after the super the super method on 55, we create an instance of battery and assign it to an attribute. That's what's happening right here on line 57. So when I do this, when I create an instance of battery, right, this is how we create an object. And the return of that is going to become an instance of the child, right? An instance variable, excuse me, yeah, an instance variable, which we refer to as an attribute. That's why this section is called instances as attributes. So this is an instance, and it is an attribute of the electric car, right? So when we go ahead and instantiate our object in the client, and we create that object, we can then use the object to access the get descriptive name. Okay. So the get descriptive name is coming from car, right? Because we inherit, right? And then the describe battery is coming from battery, right? And the get range is coming from battery as well. But how do we access them? Look at the dot notation here. It's object my underscore Tesla dot battery, which is an attribute, then dot describe battery. And if you point to these things, you know, like if I point to my Tesla, it says variable, which is an object, right? Battery, you know, which is a variable, which is an instance variable, which is an attribute. Then we have a method. So it's object, attribute, method on here. So what happens here when I run this, let's go ahead and run this. I've got the description of the car, right? That's line 64. I've got the description of the battery, which is, has a 75-watt battery. And then I have the get range. The get range method, let's take a quick look at that. The get range method says if self.battery size is equal to 75. Well, we know it's equal to 75 because we didn't provide, when we went ahead and inside of right here on 57, when we instantiated, you know, an instance of battery and assigned it to the attribute, I didn't pass anything. So if I don't pass anything, it's got 75 in it. So 75 is right in here. 75 is the battery size. So 75 as a battery will give us a range of 260. Now I have a default value here because in the book, he says we're not going to pass a value, but what if I do want to pass a value? Let's go ahead and give that little demo here. So I'm going to comment that out, and I'm going to do line 58, which instead of not passing it anything, which gives us a default value of 75, I'm going to pass it 100. So let's go ahead and see what happens when we do that. In this particular case, the method for the descriptive name fires, the method for the battery, describe battery fires, and the method for the range fires. But look at the range now. The range uses this test right here, and LF tested to see if battery size was equal to 100. And it was set to 100, right? Because I went ahead and instantiated it to be 100. Okay, so that's an example of I mean, he just did his demo with a default, and I did my demo, with you without a default. Okay, so run it again just to make sure it's running the right way. In this particular case. So now it goes back to the way it was. It says it's a 75 watt battery and the range is 260. Okay, great. So as you can see here, modeling real world objects, you can begin to model more complicated things like electrical cars. Or when you're doing this, you're going to be wrestling with some interesting questions. So these questions are at a higher logical level rather than a syntax focus level. So we're moving up. The question is, how do we model these things? So we've got to be at a higher level of logic, and we're well beyond just focusing on syntax problems. So you're thinking not about Python, but about how to represent the real world in code. When you reach this level, you realize that there are often no right or wrong approaches to modeling real-world situations. Some of the approaches are more efficient than others, but it takes practice to find the most efficient representations. If your code is working as you want it to, you're doing good, right? You may end up ripping apart your classes and rewriting them several times using different approaches. In the quest to write accurate, efficient code, everyone goes through this. So it's good that he talked about this, but one thing lacking on here is that a lot of programmers will represent their code graphically first before they, especially if it's a large project, they'll use something like UML to go ahead and model out the solution graphically before they start even messing with typing in the code. So let's go ahead and talk about the try it yourselves, and let's just take it one step at a time. Start with 9.6. And in 9.6, it's the ice cream stand. And it says an ice cream stand is a specific kind of restaurant. Write a class called ice cream stand that inherits from restaurant class you wrote in exercise 9.1 or exercise 9.4. Either version of the class will work. Just pick the one you like better. Add an attribute called flavors that stores a list of ice cream flavors. That's a list, right? So no, add an attribute that stores a list. Okay, so I got it. So stores a list of ice cream flavors. Write a method that displays these flavors. Create an instance of ice cream stand and then call this method. Okay. All right, so let's go ahead and I'm going to collapse everything so we can just see what we got. So here you see the simplest representation on here. On line 1, that's going to end up being the parent. Line 28, that's going to end up being the child. And then on line 43 to 47, well, that's the client. That's what's going to end up using the service represented by classes, right? All right, so let me just review restaurant first before we start drilling down on this. So it's got an init method. It's got some special behaviors to describe the restaurant, to open the restaurant, set number served, increment served. And so we're not going to be using all of these. That's why he said just choose any one you want. So what's going to be happening here? Where's the magic happening here? The magic is going to be happening in the child. So in the child, in the init method, I call the super method, I call the init method of the parent, right? And so what that does is that gives me the ability to take advantage of this code without writing it, which would be name, cuisine, and the number served, right? Then I create on line 34 the flavors list. So because they said create a list. So it's not going to be populated now. It's going to be populated later. And in the child class, we also have a method called show the flavors, right? So the first thing we're going to do is we're going to go ahead and instantiate an object on line 43. And we're going to give it the name called the big one. That's a strange name for an ice cream stand, don't you think? You know, that's kind of weird, right? But we'll just go along, you know, with the idea on here. And we're going to then go ahead and on the next line 44, we're going to go ahead and say object.flavors gets, and then we're going to populate that list. So here we have flavors was not populated. It was an empty list, right? So what we're going to do is we're going to go ahead and populate the list here. Then we're going to describe the restaurant. So big one dot describe restaurant. That's inside of the describe restaurant is inside of the parent class. And then we're going to call the show flavors method, which is inside of the child class. So inside of the child class, we're going to use a loop to iterate through the flavors in the list. So this is, we've done this before with lists. The only thing that's different here is the self keyword, right? Which represents the current instance. That's the only difference now compared to what we learned before when we covered the chapter on lists and how to iterate through the list. It's just that one little word right there. If it looks strange, you just say, hey, it's only one little word different. Okay, so let me go ahead and run this. But I guess I'll run it. Let me run it one time so you can just see what it does. I should have probably, let me delete the previous code so we can see it clean. So the big one serves wonderful ice cream. Okay, and how does that happen? Is because we call the describe restaurant. So if you go and look at describe restaurant, it says self.name. So that's the big one serves, and the you know, the type is ice cream. Right. Let's go ahead and do the step into, because the other one here is flavors, and the flavors get show flavors get populated, you know, inside of the child. So what I want to do is I want to just do a step into. So let's go ahead and see the logic of this. I'm going to put a breakpoint right here on the instantiation of the object, and then walk through it. Okay. So I'm going to go ahead and go run, start debugging, Python file, and let's just press F11 and walk through this. So this is the line that's going to get executed, but hasn't gotten executed yet. So when I press F11, what happens? It comes to the init. It goes to the ice cream class, which is the child of restaurant. So it's going to call super. Okay, it's going to call super. See, look at the init method for the child. It's got self, name, and it's got a default type of ice cream. Okay, so it's going to go ahead and call the, look what happens when I press F11. It's going to go ahead and jump to the parent, and it's going to put the name in there, and the cuisine type goes in there, and then number served, right? So then it comes back down here, and then goes, you know, it goes, it's already populated with ice cream because this supersedes that, right? So now we go and create our little list, an empty list, shall I say, right? And then we come back down to the client and go to the next line. The next line populates the list. And then after it populates the list, we go and call the describe restaurant, which is in the parent. And the big one serves wonderful what? Ice cream, because it ended up getting ice cream popping into there, right? And then show the flavors. This where we go ahead and iterate through the list. See, it's listing, it's going through the list, and then finally we terminate on there. So that's an example of the logic. Hopefully that showed you how the parent, the child, and the service work together. Let's go ahead and look at another example. This is 9.7 called admin. The administrator is a special kind of user. Write a class called admin that inherits from the user class that you wrote in exercise 9.3 or 9.5. Add an attribute privileges that stores a list of strings like can add a post, can delete a post, can ban user, and so on. Write a method called show privileges that lists the administrator's set of privileges. Create an instance of admin and call your method. All right, so let's go ahead and let me get rid of this so we can see all the code. Let me collapse it. I hope that this helps you understand the structure of this program on here. So basically, again, here on line 1, we've got the parent. On line 33, we've got the child. And then from 48 down to 62, we've got the client. So basically what we're going to be doing is we're going to be creating an instance of the admin class, which is the child, right? Then we're going to be using methods and populating the attribute and then showing us what privileges are available by means of a method. But before we do that, let's drill down on the parent. When we drill down on the parent, we notice that we've got an init method that receives first name, last name, username, email, and location. It's got a method to describe the user, to greet the user, increment. So it's got some of these we're not using. And that's why he says use any one you want, you know, on there. So it's not, it's a general parent. Inside the child, and this is the child on line 33 because we say class admin and we pass user. That means that we're going to be inheriting from user. We're going to have access to all this. Inside of our init method, will have self, it has to have self, right? Which represents the instance itself. First name, last name, username, email, location. We're going to go ahead and call the init method from the parent so that we don't have to type in that code. And then here's what we add. We're going to go ahead and add a list as an attribute, and it's an empty list. Very similar idea to what we did before. Then we're going to go ahead and create a method that iterates through that list. And again, this is the same as we've learned before. The only thing new here is the self keyword as we iterate through the list in this loop. All right, so then we go ahead and create an object, and we use that object to access the describe user method in the parent. We set the privileges, and then we call the method to show the privileges. Let's do a step into on this one as well. So let's go ahead, and I'm going to go ahead and put a breakpoint right there, and let's go ahead and go run, start debugging, and let's go ahead and press F11 as we walk through this. So we're going to instantiate an object right here. This object is going to be called Eric, and this Eric is going to be an object of the admin class, which inherits from user. So we're going to pass Eric Mathis, then his username, email address, and state. So it comes over here to the init method of admin, and it calls the super. Press F11, and boom, it pops to the parent and goes through all those lines of code without me having to write them. Then it comes back to the line from which it was called and goes and adds the list called privileges. Now this is an empty list, and it is an attribute of admin. Then we go ahead and come back to the instantiation of the object because it's finished doing that, and goes and calls describe user, which goes to the parent and goes through and describes the user, and then goes and sets the privileges. Remember, because privileges was empty. And then finally, we're going to go ahead and show the privileges by iterating through the privileges in a loop. And we finally close. All right, so hopefully you found that informative. Let's go ahead and go on to the next one, 9.8 on here. And 9.8 says, write a separate privileges class. This class should have one attribute privileges that stores a list of strings as described in 7.9, in 9.7. Move the show privileges method to this class. Make a privileges instance as an attribute. In the admin class, create a new instance of admin and use your method to show the privileges. Okay, so let me go ahead and collapse this one as well. I mean, that's the way I like to start. I like to see the structure of this. So here we have on line 1, the parent. Then we have the child on line 33. And then what happened was, you know, we're going to assume that the classes were getting too big, so we separated out as a separate class privileges from user. So the magic is going to be happening in here. We added an attribute instead of having it as an attribute inside of user, we put it in a separate class. Okay. So this init method here adds this attribute. Then what we're going to do is we're going to go ahead and iterate through the privileges. All right, so that's the extra class, separate class that was created. How does all this magic happen? It happens, this is the client, right? And first thing we do on line 60 is we create an object called Eric, and we instantiate it and pass it these string variables, and we describe Eric. You can already imagine in your head. Then we show the privileges, which is none, right? Because it's an empty list, right? Then we add the privileges to the list. And then we go ahead, we create our list. And adding it to the list, 2 parts. Number 1, we create the list called Eric_privileges. And we pass that to Eric.privileges gets Eric_privileges. So we pass the list to the attribute and then show the privileges. Okay, so here we see the privileges down below. All right, I'll go ahead and spare you on the step through on this, since I know that you can go ahead and do that on your own. The next one on here is battery upgrade. Use the final version of electric car. .py from the section, add a method to battery called upgrade battery. This method should check the battery size and set the capacity to 100 if it isn't. Make an electric car with a default size and call get range once, and then call get range a second time after the upgrade of the battery. You should see an increase in the car's range. Okay, so that sounds pretty cool. Let's collapse this to see what's going on. All right, so what do I have here? I have line 1, I've got the parent. Line 2, I've got the battery that was created into a separate class. Apparently, I guess the idea is that car was getting too big, you know, so we went ahead and separated that. Then we have electric car. So let's, which is the child. And then we have the service from 78 to 84. Which uses the services. So let's just look at the car real fast. It's got an init method, some simple little methods to describe, read, update, and increment. Okay, nothing that we probably need to pay too much attention to here. It's probably got more stuff than what we need in here. So we're going to close class, come to battery, and what we did here is we created a default an attribute, right? We're going to set it to 75, and that will go into effect if no battery size is provided. Okay, so battery size is then set to self dot, self dot battery size this is how the attribute is set for battery. Then we've got a special method to describe the battery and another special method to get the range. Notice how it checks if the battery size is either 75 or 100, and it sets the range variable and then provides feedback. Okay. The upgrade battery is a method that has been added that performs a test to see if the battery size is equal to 100. Then it prints that the upgrade, that we need to go ahead and upgrade the battery to 100. Else print the battery is already upgraded. Okay. So that looks about it on here. Again, let's just go over this last method one more time. We say if the battery size is equal to 100, equal to 75, what we're doing is we're upgrading. You have to understand the logic on here. In other words, we're assuming that 75 is too low. So if it's just 75, then set battery size to 100. See, remember here, this is the test for equality. Let's don't forget that. Two equal signs is the test for equality. You're saying, hey, are these two things equal? If they are, then assign 100 to battery size. I want to make sure that everybody understands the difference between line 58 and 59. Let's go ahead and run it real fast. So it says the car can go approximately 260. So because first of all, it creates an instance, right? It says make an electric car and check the range. So it says make an electric car and check the range. Fine. That's kind of like the beginning of the program, right? Then we create our instance on 79 and we go ahead and get the range. So the range says this car can go approximately 260. Why can it go 260? Because it only has 75 kilowatt battery. Then what we go ahead and do is we say upgrade the battery. So what we're going to be doing is if we're upgrading the battery, we're saying, hey, if it's got 75, make it a 100, which we know it's 75 because we created an optional attribute of 75. So then the printout then says upgrade the battery to 100, and then finally it says this car can go approximately 315 miles on a full range. I will do the step into this as this is our last one on here, just to hopefully get a better appreciation for the logic of this program or the flow of control. I'm going to put my breakpoint right here on line 78, actually 79. And let's go ahead and go run, start debugging, and Python file. I'm going to just press F11, which is the step into it. So it says, make an electric car and check the range. So that line 78 was run. So now it's stopped on this line, and it's going to, if I press F11, it's going to go and create this object called my Tesla. So it creates an electric car, and we know electric car inherits from car. So the super method will call the parent's init method and pass manufacturer, model, and year. See how it passes those three. And then it sets the odometer reading to 0. Then after the super method, we go ahead and add the specific instance of the battery and assign it to an attribute. That's remember that new class called battery, it's now going to end up being an attribute, right? So we end up going into battery and it's set to 75, right? So then we go ahead and get the range, and the range tests to see, and it is 75, so it prints the range of 260, and it says this car can go approximately, how many? 260 miles. I'm pointing to it. And we go on to upgrade the battery and check the range again. And we come in and check the range again to see, if it's equal to 75. And it fires at 100 because it went ahead. It was set 75, so then it was set to 100, and it's going to upgrade it. It says upgraded the battery to 100. It did upgrade it because it's now set to 100. Before it was set to 75, and I saw that change before. And when I was pointing to it, it said 75, but as soon as I got to 59, it changed that 75 to 100. So we upgraded the battery, and now we're going to go ahead and test for the range. So you think this one is going to fire? No, because battery size is 100. So it's going to go and do the LF, and the range is going to be 315. Okay. Well, that, my friends, is a small introduction to inheritance. There's really a lot more to this that you will learn in more advanced classes, specifically related to concepts of polymorphism and things like that. But other than that, I hope you learned a whole lot. And remember, I do think it's important for you to be checking the cheat sheets, so that you don't forget. Let me go ahead and show that to you here. I like to look at them before and after I cover something. Like, for example, we went ahead and talked about class inheritance in this little video. And class inheritance, as it says here, if the class you're writing is a specialized version of another class, you can use inheritance. When one class inherits from another, it automatically takes on all the attributes and methods of the parent class. The child class is free to introduce new attributes and methods and override attributes and methods of the parent class. To inherit from another class, include the name of the parent class in parentheses when defining the new class. So this is an example here, such as the electric car. Other topics that were covered was talking about the finding your workload and modeling real world objects. And, as you can see here, he gives some examples of overriding instances as attributes. And we're going to be talking about importing classes in our next video. So as you can see, there's a lot of great stuff on here. So if you're still a little fuzzy on self, understanding what self is, or understanding what the init method is. So what he does is he brings out topics and puts them on here. I've never printed one of these, but I've thought about it. But it's easy enough to just read them on the screen, and I highly recommend them. So here it is, Introduction to Inheritance, and Professor Benavides, over and out.